Hi, this is video 2 from chapter 13 of Absolute Java, and the focus of this video is java.lang.Comparable. This video provides an example of the use of probably the most popular interface, Comparable, and to see the power of this interface that is provided by Oracle. Now, chapter 6 discussed the selection sort algorithm on pages 384 to 386. And examined a method for sorting a partially filled array of type double into increasing order. And this code could be easily modified to sort into decreasing order or to sort integers or strings instead. And each of these modifications in the methods would be essentially the same, but making these modifications for an integer, for a string, for a short, for a long would be a nuisance. The only difference would be the types of values being sorted and the definition of the ordering. Now, using the comparable interface could provide a single sorting method that covers all of these cases. So first, we will review the double base sort from 384 to 386. And then we will modify this to use a general purpose sort using comparables. Now remember the selection sort. The selection sort started at index 0 and compared the element in index 0 against every element in the rest of the array to find the smallest index. After passing through the array, it would swap the smallest value with the 0 value. It would then know that the 0 value is the smallest. It would then do another pass starting at index 1 and look at the rest of the array. So here, the smallest value, the value in index 0 is 8. We're going to walk the rest of the array to find the index of the smallest value in the array. So we see that at index 4, there's a value of 3. That's the smallest value in the array. So we are going to interchange the values in index 0 with the values of index 4. So the 3 and 8 change places. We now know that 3 in the 0 index is the smallest value in the array. Our concern now is to look at the first index and to compare that value against every value in the rest of the array to find the smallest value. In this case, we find a 5. So we're going to interchange 5 with 6. And we now know that the first two values in the array are sorted and the smallest two. We will then go on to index 2 and repeat the process until the entire array is sorted. So the code for this selection sort is shown here. We had an empty 0R constructor. We have a sort method that's taking a parameter A, which is an array of doubles. And it simply has a for loop that's going to walk through the array starting at index 0 all the way to the end, increasing the index by 1 each time. And each time through it's going to find the index of the next smallest element and then interchange the two values. The method for the index of smallest is shown here. It takes a start index and an array of doubles. It's going to compare the start index against every other index in the array to see who holds the smallest value. It will return the index that contains the smallest value. We then have the interchange method that takes the two indices to be swapped and swaps those two values. We have a main method to prove that it works. The main method is going to create an instance of selection sort demo and call the method go. When we create the instance of selection sort demo, we get an instance variable B that's an array of doubles with the following values. The go method prints out the array before we sort. It calls the sort method with the array, so the sort will take place within the current array. We're then going to print out the array values to show that the sort did work and place the values in ascending order. And we know from chapter 6 that works. Now let's take a look at the comparable interface. Here I'm showing you the Java doc from docs.oracle.com for the version 7 of Comparable. And don't worry right now about this less than sign, t greater than sign. These are generics that we will cover in a subsequent chapter. But right now, Comparable is an interface provided to us by Oracle. In many classes, many Oracle classes implement this interface. And in pink, I'm showing you a lot of the wrapper classes that do, such as character, boolean, byte, double, float, integer, long, short. And the Comparable interface has one method heading that we need to provide the body of if we implement this interface. And we're going to talk about the details of this in length in subsequent slides. But for now, just notice that the returns. It returns a negative integer, 0, or a positive integer. If this object is less than, equal to, or greater than the specified object. Okay, so we're returning an integer. Now I mentioned before that a number of classes provided by Oracle implement the Comparable interface. So here's a class double that we've used quite a bit. And you can see here that it implements the Comparable interface. We see a class string also implements the Comparable interface, so we can compare strings with it. And we're going to create our own classes that implement the Comparable interface. So let's get more into detail. The Comparable interface is in the java.lang package. So it's automatically available to any program. It has only one method heading that must be implemented. Public int returns an int now, compared to in a parameter other of type object. And it's our responsibility as programmers to follow the semantics of the Comparable interface when implementing it. So the method compared to must return a negative int number if the calling object comes before the parameter other. Returns a 0 if the calling object equals the parameter other. And returns a positive int if the calling object comes after the parameter other. If the parameter other is not of the same type as the class being defined, then a class cast exception should be thrown. So semantics. Almost any reasonable notion of comes before is acceptable. In particular, all of the standard less than relations on numbers and lexicographic ordering on strings are suitable. The relationship comes after is just the reverse of comes before. So as class designers, if we have a class student, what does less than? What does equal? What does compare to mean on a student? Could be GPA, could be the number of credit hours. I'll say we had a class car. What does less than mean for a car? Is it the cost? Is it the mileage? Is it the seating capacity? So the ordering is going to be up to us, but it needs to be a total ordering. Such an ordering must satisfy the following rules. For no object O does O come before O. That makes sense. For any two objects O1 and O2, one and only one of the following holds true. O1 can come before O2, O1 can come after O2, or O1 can be equal O2. Makes sense. In transitivity, if O1 comes before O2 and O2 comes before O3, then O1 comes before O3. And the equals of the compared to method semantics should coincide with the equals method if possible, but this is not a requirement that's checked. So the next example is going to rework our selection sort class from chapter 6. This new version, generalized selection sort, includes a method that can sort any partially filled array as long as the base type implements the Comparable interface. And it also contains the appropriate modified index of smallest and interchange methods. Now, as I showed you before, both the double and string classes implement the comparable interfaces. Well, interfaces apply to classes only. And so when we have primitive types like double, int, long, char, those cannot implement an interface. So we need to use one of the wrapper classes like double, character, or long if we want to put those into a generalized selection sort. So here, to change things up, let's use our own class. Let's create a class called student, and we'll implement comparable. And we're going to have a last name and a first name that I don't show here. We're going to provide our compare_to method. It's going to return an int. And just thinking about polymorphism in types, we can create a variable a student of type student and put into that an instance of student. But because a student implements comparable, I can also put a student instance into a variable of type comparable. Similarly, I could create an array of students and put it into a students variable that's an array of students, but I could also put that same array into a variable called cstudents that's an array of comparables, because every student is a descendant of comparable. Comparable is a parent class or parent type. So writing the generalized selection sort, here in pink, I show the one change to the method sort. We are now going to declare a parameter a that's an array of comparables, where before a was an array of doubles. So as long as our class implements comparable, we can call sort on it. We also need to modify the index of smallest and interchange. So here I have parameter a that's an array of comparables instead of a being an array of doubles. I'm going to grab the value in the starting index and put it into a local variable min of type comparable, where before min was of type double. And in my for loop, when I'm comparing the values at each index, I'm going to call compare_to on the index that I'm looking at, and I'm going to compare that against the smallest value I have to date. And if my calling object, in this case, the object at index in the array is a negative integer, so it's less than 0, I know it's smaller than min, and I'll set min to be equal to the value at this index. That's the index that I return. In terms of the interchange method, I pass it a parameter a that's an array of comparables, and I'm just going to switch the values between the indexes I and j. Before I had a temp of doubles, I now have a temp of comparables. So you can see the changes were very few. But now I can use this sort on any class that implements comparable. So here's my student class again. And here I'm implementing comparable along with serializable and clonable, and I'll talk more about those in video 3 and 4. But I've got a first name and last name. And here's my compare_to that I'm providing the body for. So an object, A0 comes in. If the object I pass in is not of the same class of student, I'm going to throw a class cast exception. Otherwise, I'm going to cast A0 into a student instance that I call A student. And I want to compare the last name of the calling object against the last name of A student. If those are different, I'm done. I'll know whether the last name is less than or greater than. But if the result is 0, I want to use first name as the means to break the tie. Again, I can write a main method to test this out. So I created an array of 3 students. I instantiated students to put into those 3 different indices. I print out the array to show what it looks like before I call sort. We call the new sort on this array of students or array of comparables, and then print them out to verify that they come out in sorted order. And sure enough, they do. Duval, Hollingsworth, Powell. So in summary, comparable is a nice example of an interface. It allows a generalized sort routine to work with any class that implements comparable. It will work with classes that are not even developed yet. And this is the best practice for you to consider. In any class that you implement, any class that you design, any class that you write, should you implement comparable on your design classes to give it some flexibility in its use down the road. That concludes this lecture. Have a great day.